Welcome, everyone. This is the Cognitive Training Webinar Series kickoff. We will be setting the stage today for this series. I am Melissa Treviño from the National Institute on Aging and the NIH, and I am part of the steering committee for this webinar series. And we are recording this webinar today and the presentations and discussions, and they will be publicly posted. So I want to acknowledge the entire steering committee who is providing scientific oversight, Dr. Susanne Jaeggi, Vankee Lin, and Wally Boot, who will be speaking shortly, and Dr. Kristina Hardy, who will be moderating today's session. So for the webinar series, we will be defining cognitive training as interventions using cognitive tasks or intellectually demanding activities with the goal of which to enhance general cognitive ability or cognitive functioning in the real world. So I first wanted to go through a brief historical background in cognitive training. In 2014, there was significant press attention on the ACTIVE trial, which just published its 10 years outcome. And ACTIVE stands for Advanced Cognitive Training for Independent and Vital Elderly. And the ACTIVE trial laid the foundation for the field. It differed from earlier studies in that it recruited a relatively healthy sample of older adults. And it was the first large-scale, multi-site, randomized trial to look at efficacy of different types of cognitive training on cognitive performance and everyday functioning. And it had follow-ups extending through 5 and 10 years post-intervention. The average age of participants were 73, and the trial looked at 3 cognitive training interventions: memory, reasoning, and speed of processing. The memory training focused on improving verbal episodic memory through instruction and practice and strategies. And reasoning training focused on improving the ability to solve problems that follow a serial pattern. So for example, identifying a pattern in a series of letters. And speed of processing training focused on visual search skills and the ability to identify and locate visual information quickly. And the ACTIVE trial did show a 10-year benefit in reasoning and speed of processing. So there is a bit to unpack in these figures, but I will highlight key takeaways. So the figures display mean scores for reasoning on the top and speed of processing at the bottom. And each figure graphs performance for the 3 different training groups and control at each time point. So higher scores indicate better performance. So if you did reasoning training, it resulted in improved reasoning for 10 years. And if you did speed of processing training, it resulted in improved speed of processing at 10 years out. Additionally, not shown, all 3 intervention groups resulted in less decline in self-reported everyday function compared with the control group at 10 years. At the same time that the ACTIVE trial published its 10-year outcomes, part of the scientific community put out an open letter signed by a group of psychologists and neuroscientists who objected the claim that cognitive training, as more specifically the marketed brain games, could reduce or reverse cognitive decline, stating that there was no compelling scientific evidence today that they were effective. And a few months later, another group of scientists countered with their own open letter and took the opposite stand that there was a substantial and growing body of evidence that shows certain cognitive trainings can improve cognitive function. In 2016, NIA commissioned a AHRQ review on the prevention of age-related cognitive decline, mild cognitive impairment, and Alzheimer's disease. The review was informed by the NACIM Committee on Preventing Dementia and Cognitive Impairment, and the committee released the report in 2017 and identified cognitive training as one of 3 areas in need of further research. And the report found the evidence for the beneficial impacts of cognitive training to be encouraging, but inconclusive. The report had other important recommendations, such as starting interventions at younger ages and having longer follow-up and having increased participation of underrepresented populations. And six, since active and the NACIM report, there has been a multitude of cognitive training studies. This is a Bashak et al. Meta-analysis that reviewed 250 studies and showed significant benefits of cognitive training for both mild cognitive impairment and healthy aging groups. And I do want to note that empirically, even meta-analyses are mixed, with some that do find effects and while others do not. And Dr. Boot will touch on this a little more in his talk. So why do a webinar series on cognitive training? Given the salient 2017 NACIM report and the promising cognitive training evidence, as well as cognitive training is a low-cost, non-invasive intervention that has a benign side effect profile. And I have spoken from the perspective of aging and the prevention of Alzheimer's disease, but there may be a lot of different use cases that are applicable to cognitive training. The goal of the webinar is to understand the gaps and opportunities in cognitive training research to help further research to strengthen the evidence base. So we have 4 additional webinars planned. The webinars will be broken up to target key questions, and the QR code links to the webinar website, so please register for the additional webinars. Webinar 2 will focus on underlying mechanisms, and there we will discuss does cognitive training generalize or transfer and how. Webinar 3 will concentrate on outcomes. What are the important outcomes, and dive more into near and far transfer effects. Webinar 4 will concentrate on moderators and mediators. So for whom does cognitive training work and why and in what context? And webinar 5 will be looking at the future of cognitive training. So what can we do to make cognitive training work better? So looking at adherence, engagement, and motivation. Our steering committee also identified 3 cross-cutting themes and issues to guide our thinking and our discussions over the course of the webinars. So the first is scalability, reproducibility, and generalizability. So thinking about what are we doing about the science now that we should be doing differently to make sure that these issues are addressed. And then diversity, equity, and inclusion. How do we ensure studies have diverse and inclusive representation and are culturally appropriate? And then looking at best practices and future directions. So what are the best practices in terms of research and in terms of intervention implementation? And so I want to go over some webinar expectations. So please mute yourself and use the chat function. So please use chat to ask your questions, to share any resources. The moderator will read your question or call on you to further elaborate during the general discussion section. And as I mentioned before, webinars will be recorded and a summary will be accessible. So if you have any questions, please direct them to Mariana Molina or Jennifer Adona. So now I will turn it over to Dr. Kristina Hardy from the National Institute of Neurological Disorders and Stroke, who will be moderating today's session.
Hi, everybody. I am so pleased to be joining you all for this introductory webinar. As Melissa so wonderfully summarized, we are 10 years past the publication of the results of the active trial and concurrent scientific concerns about the possible efficacy of cognitive training. Our committee really wanted to kick off our series by exploring some key questions with presentations from our panel of expert investigators. Among these is really the key question of, does cognitive training work? But also why that might not be the best question to be asking. So our panel of experts are going to really give us some nice presentations over the next hour about what we've learned from cognitive training in the past decade. And then hopefully we'll follow this by a robust discussion with some questions about where to go from here. Melissa, do you want to introduce Dr. Lin? Or I can.
Oh, yes. Thank you. So next up is Dr. Vankee Lin from Stanford University, who will kick off these talks.
Can you hear me now? Okay, thanks. Morning and afternoon, everyone. I'm very glad to be part of a webinar series and to share my insight on cognitive training and brain aging research we learned from the past decade. As many of you know, cognitive training within non-pharmacological intervention remains a highly debated topic. Public discourse often reflects skepticism, especially when you scan through the news outlet. The skepticism, especially prevalent within the basic science field, stem from various factors. The clinical effectiveness of cognitive training, especially the prediction of gains, has been restricted by its relatively narrow impact. The absence of large-scale trials demonstrating robust and widespread training effects that carry clinical significance is limited. A recent workshop paper from Alzheimer's Association attributes this limitation to inefficiencies in the design of cognitive training programs, largely rooted in the absence of a coherent mechanistic framework guiding the development and evaluation. Therefore, my brief talk today will focus on illustrating the mechanistic framework for cognitive training and emphasize why researchers in the brain aging and the dementia fields should consider its conceptual and operational aspect. The essential component is the Science of Behavior Change Framework from NIH, which is designed to provide a systematic approach to understanding and implementing evidence-based intervention that effectively initiate and sustain behavior changes. It employs a mechanism-based approach focusing on identifying and targeting the underlying processes that drive changes in behavior, such as the biological, psychological, and the social pathways. In the context of cognitive training within the field of brain aging and dementia, it's essential that we carefully consider several aspects of the framework. This includes designing a component of cognitive training, effectively engaging the target of intervention, understanding the mechanistic pathway and the underlying this target, ensure the validity of our target, and determine the cognitive training outcomes we aim to achieve. Each of these factors play a critical role in creating intervention that are not just scientifically sound, but also practically effective in enhancing cognitive function or other outcomes for individuals experiencing brain aging and dementia. In addition to focusing on the mechanistic framework, we must also select a cognitive training-specific conceptual framework that aligns with our objective and consider the design of our trial to ensure they are both rigorous and replicable, aligning with the NIH state model guidelines. In today's talk, I will touch on each of these critical aspects, exploring how they can collectively contribute to the advancement of cognitive training methodologies in the context of brain aging. So let's begin with the outcome of cognitive training. Typically, cognitive training reliably enhances performance on the task that directly target. We call the train effect. It often also benefits similar but untrained tasks we refer to as the near transfer effect. However, extending this improvement to completely untrained domain or achieving far transfer effect remains rare. The ultimate goal of cognitive training intervention is to achieve a broader training effect, improvement not only in cognitive function, but also in neuropsychiatric symptoms or other real-world test performance. But regrettably, realizing this goal, especially in individuals at risk for dementia, is a significant challenge. In terms of mechanisms, or we call the putative targets of cognitive training, initial studies focuses on identifying participants' intrinsic brain profiles that predict changes induced by training. An illustrative example comes from Desposito's research, which demonstrates how baseline brain modularity means the brain. It is about how the brain is organized into distinct networks that perform specific tasks, can predict functional gains from exercise. Building on this foundational understanding, more recent work, including ours, has progressed to exploring changes in brain profile that underlie the mechanism of cognitive training. For instance, in our latest studies targeting speech processing attention, we measured the participation coefficient. This metric quantifies how well the brain connects across various networks, facilitating the integration of information between functionally specialized modules. Our finding reveal that enhancing the resting state participation coefficient of the ventral attention network, which mirrors the integration of this brain network with others, substantially explain how cognitive training can lead to far transfer effect, notably improving working memory. This not only underscores the importance of integrative neural processes, but also highlights potential intervention targets for enhancing cognitive function. Another aspect of the mechanism or putative target for brain aging that is rarely mentioned is the peripheral mechanism, such as the autonomic nervous system, ANS. This novel discovery emphasizes how individuals' adaptation to cognitive training demands influenced by the ANS determine the optimal mismatch between cognitive training demands and the person's brain capacity. I have developed a framework suggesting the initial suppression and the subsequent rebound of the parasympathetic branch of autonomic nervous system during cognitive challenges indicate adaptation capacity. Our lab's previous work established that the physiological signal reflecting the ANS function provide a measure of adaptation capacity that predict improvement following cognitive training. We refer this ANS pattern as harmful because it reflects the rebound phase. Essentially, what we found was older adults whose baseline ANS patterns were less similar to this harmful pattern, and if the harmful pattern occurred later during a cognitive training session, would benefit more from cognitive training in terms of learning and neuroplasticity. Furthermore, methodologically, establishing causality is crucial for identifying the role of proposed mechanisms and evaluating whether a target is valid for producing the expected outcome changes. I would like to highlight some innovative methods for specifying causality that we have incorporated into our recent work on cognitive training. One such method involves novel ways of conducting experimental manipulation using non-pharmacological strategies, which we termed as the stage 0 mechanistic intervention approach. This approach allows us to test the direct effect of intervention on proposed mechanism in a controlled environment. Additionally, we are exploring emerging inductive computational models on counterfactory effect. For example, we ask questions such as, what if we target group B instead of group A? Can the intervention have the same effect on the outcome? This differs from traditional deductive moderation analysis by focusing on the specificity of a mechanism rather than merely testing its sensitivity. Moreover, we are clarifying mechanisms using non-human animal models, which provide a more controlled setting to isolate and examine the effect of cognitive training interventions without the confounding variables often present in human studies. These methodological advancements are critical for deepening our understanding of cognitive training's effect and for designing interventions that are both effective and scientifically grounded. Now let's move on to the cognitive training ingredients and how to ensure an engagement of the target. We have recently developed guidelines to integrate both the cognitive training ingredients and how to personalize intervention component into the cognitive training design. In terms of the modality, we may consider a single modality cognitive training, such as focusing solely on attention and processing speed as seen in the active trial, or a multimodality approach that include attention, cognitive control, working memory, and others. For personalizing engagement on the training state, we emphasize the role of a closed loop approach. This dynamic method continuously monitors a person's performance and the neurophysiological responses, providing real-time feedback to adjust the training task, therefore optimizing the engagement. However, not all the personalization strategies need to be closed loop. There are other intermediate strategies we refer to as pseudo personalization. The most common example is to tailor cognitive training difficulty based on a person's reaction time and the accuracy in previous training trials, or called the staircase design. Two additional differentiation I would like to briefly mention. First, the precision medicine approach often emphasizes personalization towards a trait or a person's intrinsic baseline characteristics. However, an important aspect of personalization for engagement in cognitive training, as I emphasize, is to personalize the real-time state during training. And the second, the modality of intervention ingredient may refer to cognitive training alone or cognitive training combined with other intervention modalities, such as in finger trials, they combine cognitive training with exercise, diet, and vascular risk monitoring. Designing intervention ingredient and choosing targeted mechanism and outcome of cognitive training, also relying on having a specific and scientifically solid conceptual framework. Here, I outline several conceptual frameworks specifically for cognitive training. So the Lofton schematic model of mismatch emphasizes the dynamic changes between brain capacity and the demand provided in cognitive training. Van Basten's capacity efficiency model of cognitive training and transfer provides measurable moderators we should consider in cognitive training. And our work on unifying the cognitive training framework for brain aging emphasizes how we can integrate the population and the individual level factors into cognitive training design to induce broader training effect by enhancing brain topology and targeting at-risk populations. Ultimately, individual researchers should choose the framework that best aligns with their specific research questions and objectives to design effective and personalized cognitive training interventions. Also, we need to carefully consider the stage of cognitive training or intervention design. In our recent guidelines, we integrated an NIH stage model with the study of mechanisms, incorporating both the stage of science of behavior change, which study mechanisms as mediators, and the precision medicine, which study mechanisms as moderators. The NIH stage model outlines a progression from stage 0 mechanistic study to stage 5 dissemination. As shown in this table, depending on the purpose of a cognitive training study, there are specific requirements for the intervention stage. Additionally, we may be able to concurrently or solely study mechanisms as either mediators or moderators. I will end my talk with some examples surrounding speech processing attention training from my lab to give you a more concrete understanding of cognitive training. We mentioned the active study before, which is a single modality of double decision training paradigm combined with a pseudo personalization strategy based on real-time test performance. This study targeted attention processing speed by comparing with other intervention arms and consider everyday speed and the function as the primary outcome. More recent work in using the same categories of speed processing and attention training, but involving more multimodality training with attention control and working memory while still employing pseudo personalization strategies. This study targets brain topology and autonomic nervous system adaptation. Consider processing speed and attention as primary outcomes and the working memory as the secondary outcome. We are also in the process of testing a cognitive training program on multimodality tasks with closed-loop personalization based on real-time test performance and physiological status. This animation demonstrates our approach. Basically, we are simultaneously collecting and processing ECG data when a person is working on the training. After every block's training, the program will decide if the processed ECG data will match our previous discovered ANS harmful pattern. If matched, the person is on the adaptive or rebound state. The program will go to a more difficult task paradigm or a novel test paradigm. But if it doesn't match our pattern, it means the person may still be on the suppression or adjusting state. The program will continue the same training test paradigm. So this is, yeah, just a little slower than what I'm showing, but yeah, it shows like it's not matched. So the other example is on cognitive training combined with other interventions. The finger trial I mentioned earlier is a multi-component clinical trial with a primary outcome on global cognition that didn't specifically address mechanism. More recently, we have been focusing on targeting specific outcomes for such multimodality intervention. For example, in the BEAM study, we examined the synergistic effect of cognitive training combined with sensory motor cortex focus non-brain stimulation, targeting the brain function with a primary outcome on mood and the secondary outcome on cognition. And in the ACT study examined the cognitive training and exercise, targeting cardiorespiratory fitness and whole brain topology as the primary outcome on cognition. And recently, there was a now intervention combining mindfulness training and exercise on cognitive function. We may want to re-examine this by considering cognitive training combined with mindfulness strategies. As a recap of the aspect of conceptual and implementation strategy for cognitive training I went over, we need to pay attention to the component of mechanisms and outcomes depending on our research demands. Choose the appropriate conceptual framework and the design for cognitive training. Okay. Thank you for your attention.
Thank you so much, Dr. Lin. That was wonderful. A great start to be able to talk about these concepts. I want to now introduce Dr. Susanne Jaeggi, who will begin our second talk.
Okay, thank you so much. Okay, are you good to go? You see my screen, you hear me?
Yep.
Excellent, great. Yeah, so hello everyone online, and thank you so much everyone for being here. So I'm really excited about this webinar series, which will hopefully result in a lot of interesting discussions and illuminating insights that will help our field to move forward. So when we talk about cognitive training, as Melissa was introducing it earlier and Vankee was showing us, there has a real increase in the literature and the amount of articles that have focused on cognitive training in recent years. So in the early 2000s, there were a handful of studies published, but really since the last couple of years, there were over 500 articles published every year. And when you think about cognitive training, despite the definition that Melissa provided earlier, so when we look at these articles, anything ranging from mindfulness meditation that Vankee I mentioned before, to playing chess, to cognitive exercises played on a computer, to active video game training, to even reading or learning languages, to art-based interventions can be subsumed under the term of cognitive training. So there's a large variety of activities that could be seen as cognitive training. And the question here is, do they all do the same thing? And the answer is probably no. When we focus a little bit more on cognitive training as it commonly is assumed of us, or what is understood under cognitive training, let's focus on brain training games. And there has been a huge market for such app or increasingly web-based games that is growing every day. So recent market analyses, for example, estimate the brain training software market at 8 billion only in the US in the past years. So this availability of these different brain training games opens huge opportunities for individuals to engage in brain training or cognitive training who might have been typically hard to reach or are underserved. On the other hand, there are clear challenges in that it is rarely evident whether these games work in the way they are marketed and whether they are effective. So back to the overall question, do brain training or does cognitive training work? Looking just at these examples that I'm presenting here, so in these different apps, there are 1,000,002 probably different games and different processes that are targeted. Everything from learning languages to memory games to problem solving. And asking, therefore, whether or not brain training works is very similar to asking the question, do drugs work? As it's true for the term brain training and cognitive training, the term drugs is a overall category that includes a incredibly variety of different chemicals and processes, from those that were very custom designed to for a very particular purpose, to others that also were discovered by chance, but that are put down in put to practical means. And they can also be delivered in a variety of different ways at different dosages, on different schedules, in endless combinations. So the question, again, whether drugs work is typically defined with respect to the stated target conditions, or also the population that they are trying to serve. Another thing to keep in mind, and we will probably come back to this question later when we talk about mechanisms, even drugs with the same real-world target, so for example, depression, they may act on completely different system and mechanisms. So if you think of antidepressants that could act on serotonin versus dopamine versus norepinephrine systems. So again, there's a really huge variety, and there's a need to be a little bit more specific when it comes to the definition of or the question about the efficacy of cognitive training, broadly speaking. So in my group, we have largely been focusing on trying to improve and maximize working memory, our mechanism or our ability to store information for a brief period of in time in service of other activities, for example, higher cognitive function. So why would we want to train working memory? Well, there's a lot of different reasons of why that could be beneficial. For example, working memory is one of the key predictors for higher cognitive functions and also scholastic achievement. Working memory is highly malleable. So from changing across human development, it is also, or it has also shown to be susceptible to the effects of experience and practice. It's also affected by many developmental clinical disorders, such as depression that I mentioned before, or also ADHD, and critically for many in this audience, aging. And there's also large individual differences to the extent to which people can keep information in mind and manipulate information. So when we look at working memory training and whether or not working memory training generalizes to other domains, one of the early questions has focused on whether or not training on working memory might impact measures of fluid intelligence, so our ability to reason, which is again a predictor for real-world outcomes. One of the early meta-analyses that we have been published in our group has focused on people who trained on NBAC training type tasks, and to the extent to which they find larger improvement after training in these measures of fluid reasoning. And we found that indeed people who completed NBAC training, so a particular type of working memory training, did better than control groups after at post-test as compared, again, to the control groups. Here is to say that the effect sizes are in the about a quarter of a standard deviation, and you could argue these are relatively small. That said, we find quite a big of a variability in terms of some studies finding larger effects and some studies finding no effects at all. And when we then did some follow-up analyses looking at the different types of trainings and the types of outcome measures that people were using, this is a very complex figure, but the important takeaway here is that on the left, we are showing different kinds of training features that were used, so that the types of modalities that were trained in the task, and on the right are the outcome measures that are illustrated. And essentially, every study uses different methods. So we're comparing a little bit of apples and oranges when comparing these different studies, which also contributed to a noisy signal. And of course, meta-analyses to some extent should look at the summary or across all these different studies. But from a practical standpoint, it's really hard from this to extract potential ingredients that could be useful or that are actually relevant to impact real-world outcomes. So when we look at the overall literature in terms of where are agreements and disagreements in terms of cognitive training, or in this case also working memory training, there's a quite broad agreement that specific cognitive skills, for example, working memory, are malleable, as I was mentioning before. So if you're training on working memory measures, if you train over time, you should get better at these specific skills, which is maybe not earth-shattering, but nonetheless, there seems to be agreement in this. There's also largely agreement that transfer to similar, so non-trained task is commonly observed. So if you train on an NBAC task, for example, with spatial stimuli, you should expect improvement to non-trained version of this NBAC task, for example, to verbal stimuli. Where the contentious actually starts is the evidence for far transfer. So the evidence of whether or not training on NBAC, for example, transferred to other measures that are not closely related to the outcomes. And the reasons for disagreements include inconsistent findings. So this is, of course, a big factor. And Dr. Wally will talk a little bit more about some of the other reasons. So there are a lot of methodological issues that are in play, and then also questions about underlying mechanisms, which we will talk more about in one of the upcoming webinars. But what we have been focusing on in our group is also figuring out what are some of the ingredients that could make training work, and what are they, and how can they be manipulated. So first of all, we have been focusing on intervention features that actually matter. So one of the first things that we focused on is training duration. So what we could demonstrate in a couple of papers is that time on task really matters. So the more and the longer you train, the more improvement you find in non-trained transfer measures. So here again, in these matrix reading type measures, capturing fluid intelligence. Again, maybe not earth-shattering in that sense. So the more you train, the more you might get benefits out of it. But nonetheless, this dose response curve we have been observing in a couple of studies. Other factors that we have been focusing on are the types of stimuli and the types of processes that we might be targeting during training. So in this study, we focused on whether showing the stimuli in a unisensory environment, only showing visual stimuli, or auditory or visual stimuli in an alternating factors, versus then combining and providing a so-called multisensory environment, which we could demonstrate that this can actually facilitate transfer in the long run. So in other words, there are a couple of different intervention features that seem to matter whether or not we find transfer effects after training. Another aspect that I wanted to highlight that we'll also be talking about in future webinars are individual differences. So here on the left, I'm showing you data from an older adult sample who underwent a NBAC training over the course of 4 weeks. And you can see there are huge differences in the extent to which they actually improve in the training. So the green curve here is a person who show really nice marked improvements across the 4 weeks. And then on the yellow curve on the bottom, which might be a little bit hard to see, we have other individuals who hardly improve at all. And the question is whether the extent of improvement matters for transfer. And it actually turns out that it does. So this is from another study in children in which we divided individuals in terms of whether they showed extensive large training gain, as in this green curve on the left, or very small training gain as the yellow curve on the left. And this is the column on the left, and you can't see this because they almost show no discernible transfer at all, and then the active control group is somewhat in the middle. So here we have a little bit of a challenge because it is hard to then also include the control group in these analyses. So in a follow-up and a series of studies that we did that also foreshadows some of the topic that we'll be talking about in the upcoming webinar on Mediator and Moderators. Here we looked at the extent to which the improvements in near transfers, so non-trained versions of the in-back task, whether or not that determines the extent of far transfer. And we could demonstrate that the extent to which people show near transfer fully mediates or really impacts how much far transfer people show. And we had a number of controls in which we don't have time right now to go into this, but this doesn't work with other types of improvements, for example, in inhibition or other types of domains. So it's really critical for people to show these near transfer effect to really learn during training. And the question is how we can get people to learn. And as it turns out that self-reported engagement, so how much people actually buy into that and dedicate to the training, matters. So the more people put engagement and effort into training, the more they improve in training. So how can we get people engaged? And one easy answer that we thought could help was, well, let's just gamify the interventions, and that will help people engage with the training, and that will help them become better with the task. So I'm showing you a glimpse here from a study in which we trained children for a couple of sessions on a NBAC type task, in which we systematically varied the number of motivational features, and then determined whether or not the addition of these motivational features could help them learn. So when we had no motivational features at all, so this was a very bland and basic task, they did show some training gain over time. And once we added all motivational features, levels and points and different structures, we actually observed that the learning improvement actually went down. So kids learned less from this fully implemented motivational feature lesson, which puzzled us a little bit in the beginning, and also showed that it's not that easy to implement motivational features in a way that is not distracting. So here I'm showing you a video of one of the first games that were developed by the Brain Game Center, in which we are trying to come up with an engaging version of an NBAC task. And you can see here, even without the sound that I left out here, it seems to be a very complicated game. People have to keep things in mind. They have to keep track of the points in the left-hand corner and on the progress bar. So even though individuals rate this as a somewhat more engaging game as opposed to very stripped down basic games, it is very hard to keep up with this. So it's really important to keep in mind what we are actually manipulating. I'm almost done here, so 2 more slides here. So another thing that we figure out here, or that we could show, is that beliefs really matter. So again, participant buy-in, the more they think that they can actually improve during training, the more they also benefit from training. And the question is here, is this just anything else than placebo effects? And here we did a series of experiments, and Wally will talk about this a little bit later on too, in which we were able to demonstrate it's actually not that simple to induce reliable placebo effects. And when we then also directly compare active control groups versus passive control groups, there's not very much of a difference, indicating that there's more to cognitive training than just these beliefs or placebo effects. And I'm hoping we can talk about this a little bit more. So I'm leaving this out here in the interest of time, but my conclusion is here that we should not focus on whether cognitive training works, but we should really continue to ask what type of cognitive training works, why, and for whom. It's really important to determine the underlying mechanisms and relevant training features. Not all training approaches are the same. And very important, consider individual differences, because not all individuals are the same. And with that, I'm done with my talk. Thank you so much.
Thank you, Dr. Jaeggi. That was fantastic. I am really excited for our discussion in just a few minutes. It's my pleasure now to introduce our last speaker, Dr. Wally Boot. Before I do, I want to just remind everyone that if you have questions for any of our speakers, you can put it in the chat, and we'll be curating some questions after Dr. Boot finishes, as our time allows. Dr. Boot.
Okay. Thank you. Hope everyone can hear me and see my slides. So yeah, today I'm going to be talking about methodological and statistical considerations within the field of cognitive interventions. So the central issue here is that before we begin to address the question of whether or not cognitive training works, what are the effects of cognitive training, there's been an argument that first we need to come to an agreement on what counts as evidence either for or against the efficacy of cognitive training. Until we come to that consensus, I think we're going to be stuck for a while. As Melissa presented earlier, there are dueling consensus statements. There's a lot of disagreement about the efficacy of cognitive training. And I think what we need to do first is agree on what are the types of studies that either count for or against the efficacy of cognitive training, and what are the best methodological and statistical approaches that we can take to ensure that we have robust findings that we can have confidence in. And then once we've agreed upon whether or not what counts as evidence, what doesn't count as evidence in favor of cognitive training, then we can begin to think about, have there been enough studies that meet these standards so we can draw conclusions from what's been done in the past, and what do these studies say? So there has been a lot of disagreement, and a lot of this comes down to methodological differences and challenges and statistical differences and challenges and approaches. So, for example, one methodological question we can ask is, have we been using the right control group in our studies? Control groups that account for placebo effects and demand characteristics. And there's been disagreement on this issue of whether or not we're doing a good enough job to be able to make strong causal claims about the efficacy of cognitive training. In particular, we, I think, agree now that passive control groups are probably not the best way to go. A control group that sits down or doesn't sit down, they just do nothing. You're not exposed to anything. This is unlikely to control for placebo effects, and placebo effects, of course, are changes in outcome measures, not as a result of the active ingredient of the intervention, but because someone expects to improve. So there are placebo effects and also demand characteristics of participants behaving in ways that they're expected to behave. And a control group compared to an intervention that receives a cognitive training, a control group that receives no intervention is unlikely to have any expectation of improvement, any kind of thing to suggest that they should improve on the outcome measures. So I think we are thinking that passive control groups are probably not the way to go. But even there's been an argument that active control groups in which participants do something, but that doesn't seem like a plausible intervention to improve cognition, that probably isn't the best control group to control for placebo effects and demand characteristics either. When our interventions are dynamic and adaptive, and they are, by kind of the way they present themselves, cognitive training programs, if we give a control group, for example, of watching reality television for 20 hours, obviously that's active, they're doing something, but no one would expect that to improve their cognition. So I think pharmacological interventions have it a little bit easier than us because they can hand, and this is a simplification, 2 pills to 2 groups of participants. One is placebo, one is an experimental treatment. And outwardly, they look similarly, and you, from the participant standpoint, can't tell the difference. Cognitive training interventions, it's really impossible to have a truly double-blind cognitive intervention study because people see what they get. And this is important. This is something that people have argued that maybe our interventions aren't doing enough to control for people's expectations. And we can think about, well, what exactly are people's expectations in terms of cognitive training? And they're pretty high. When we look at, this is data from our lab and some other labs, we ask people, we expose them to cognitive training, or we show them kind of a description of cognitive training, and we ask them, how likely would this training be to improve your cognitive function, your concentration, your distractibility, a variety of different cognitive measures. People report very likely, they say that cognitive training will either fairly successfully or completely successfully address these cognitive issues a large amount of time. So when we're not controlling for expectations, when we're thinking about active control groups that seem plausible, then there are challenges in terms of making causal claims that the cognitive intervention, caused these outcomes to change versus people's expectations cause things to change. And as Dr. Jaeggi has mentioned, there are studies showing that there are effects of people's expectations within cognitive training studies. This was kind of an early influential one. And just like the cognitive training literature, the literature on placebo effects and cognitive interventions is also mixed. There's some pro findings and some kind of con findings. But here's just one study suggesting that when people come into your study thinking it's a cognitive training study versus a more general study, you either see increases in fluid intelligence as measured by Ravens and other types of standardized measures versus no improvement. So there's some evidence to suggest that based on the type of intervention versus control group that people see, there are differential expectations, and there is also some evidence that should be concerning that these expectations matter. And again, a passive control group is challenging to make any causal conclusions that it was the intervention compared to a placebo effect, but even active control groups can be challenging as well. As was mentioned initially in Melissa's talk, there was a consensus statement saying cognitive training doesn't work. There was a counter consensus statement saying cognitive training, there's lots of evidence. There's lots of evidence from many studies that cognitive training works. We analyzed all of those studies that they cited as evidence in favor. I think there were over 130 studies that they cited, and many of them used passive control groups. You can see here, 11% of the papers they cited had no control groups, and then 11% were from the active trial, which had passive control groups. 17% were from other studies that had passive control groups that didn't do anything that was unlikely to control for expectation effects. So 39% of the studies overall had control groups that made it hard to draw strong conclusions that cognitive training was effective. So this is something I think that is concerning. There are studies showing that the control group can make a difference, and that placebo effects can cause cognitive outcome measures to change, even in the absence of any plausible mechanism for them to change. So when we're talking about what counts as evidence, we have published a little bit on this, thinking about what are the best control groups, and is a passive control group sufficient? Probably not. It doesn't control for lots of different experimental confounds. But even when we think about active control groups, there has to be some work done, I believe, to make sure that that active control group is producing similar expectations compared to the intervention. And I think we're getting better. I think there are a lot of studies now that are beginning to measure people's expectations as a result of cognitive training studies. And I think there are papers now that are beginning to pre-test their active control group as well to make sure that it is producing some level of expectation for improvement. So strong control groups are needed. And we also need to, I think, better understand placebo effects. So if this is something in terms of where the research agenda needs to go, I think there still needs to be a lot of work done to understand placebo effects before we can truly understand intervention effects in the context of cognitive training and the impact of expectations on cognitive performance. There are also other statistical issues that I think are things that we need to think about in terms of the number of outcomes that we have in our studies, and also the number of times we assess those outcomes. Even things as simple as controlling for type 1 errors, thinking about what's the likelihood that this result that we obtained is just due to chance. 0.05 is going to be our benchmark, and that is what we're going to use to judge whether or not we have an effect. But there's also big challenges in terms of looking at large studies with multiple outcomes over multiple years. Here's something we published a few years ago looking at aspects of the active trial, which is innovative. It's one of the best, kind of most rigorous clinical trials, cognitive intervention trials out there. But there are opportunities to think about perhaps type 1 errors playing a role in some of the findings. So in this paper we put together, we looked at, I think in this case, 84 tests of statistical significance of the different outcomes over different times, 84 tests with a p-level 0.05, you expect about 4.2 false alarms, false findings. And in terms of FAR transfer of what we're showing here, there are 4 essentially FAR transfer effects at the same time that we're expecting about 4 false alarms. So there are things that we have to think about in terms of how do we best manage this kind of tension between statistical power and getting as much information as we want, and also controlling for false alarms. So there are some things that we need to think about in terms of statistics and also reporting as well. When we really dug into the literature, we found that, and this isn't active, but some other papers that we've looked at had outcome measures that were essentially unreported, that there were a larger number of outcome measures that actually made it into the paper. And of course, there it is very, very challenging to account for type 1 error when you don't know how many comparisons are being made. I think there's been a lot of improvement recently in terms of transparency. I think there's a lot of improvement in terms of reporting, but this is still challenging, especially for evaluating literature that's already been published. There's also challenges in terms of meta-analyses as well. Meta-analyses depend, first of all, on the quality of the studies that go into the meta-analyses, and if they're using poor control groups, or if they're not correcting for type 1 error, there can be challenges there as well. But also there are a lot of experimenter degrees of freedom associated with meta-analyses too. Here's a meta-analysis I participated in looking at the action video game literature, the idea that action video games specifically, can improve perceptual and cognitive abilities. And we found that when you choose different parameters, for example, for accounting for publication bias, you either get a kind of moderate positive effect in terms of video games actually improve cognition, all the way to strong negative effects that video games are bad for cognition, depending on the parameters you choose and depending on the parameters specifically for bias correction. And there was recently a paper that was published just, I believe, a couple of weeks ago, making this case that just like we talked about experimental degrees of freedom in terms of running experiments, there's also degrees of freedom in terms of conducting meta-analyses. And when you look at the literature, sometimes the things that you would like to know about how a meta-analysis was conducted, it's not always reported. And also many of these meta-analyses are not pre-registered. So there's degrees of freedom to move basically the outcome of that meta-analysis one way or another. And as I showed you previous data set, depending on what you do in terms of parameters, you can either produce a positive or a negative effect of cognitive training there, specifically with respect to video games and action video games. So one question that has been asked is, should we give up? So this was a paper that was published not too long ago by Gobet and Sala, who have been big critics of the video game literature, the working memory literature, the cognitive training literature, pretty much any literature to suggest that there are improvements in cognition as a result of training. And they suggest their conclusion was that given the available empirical evidence on cognitive training in other fields of research, that there's a low likelihood of finding robust results, that efforts should actually be redirected to near transfer or other methods to improve cognition. I'm not saying that. I'm just saying that based on the literature and people's evaluation of the literature and the state of the statistical kind of confusion, methodological confusion that's getting better over time, some people are distrustful of the effects that have been found and are coming to the conclusion that we should give up. I don't think that that's true. And I think a lot of people on this call probably don't think that's true either, and that should be pushed back upon. But that's at least a reasonable kind of position that was recently published in a major journal. So in terms of just some concluding remarks, I mean, I think the point of my talk and thinking about these issues is that before we begin to answer that question of does cognitive training work, we need to think about what counts as evidence in favor of cognitive training, what counts as evidence against cognitive training. There have been several position papers that have been published in the last few years, and there's some agreement. And I think we're moving forward, and I think we're in a better place than we were probably 10 years ago, 15 years ago, 20 years ago. However, there are still disagreements, and those disagreements are still causing people to have come to different conclusions based on the evidence to date. And if you look at the literature, there are a lot of journals publishing lots of things, and many papers are still publishing papers that do not meet the standards I think we're beginning to agree upon, and subsequently are used as support for or against the efficacy of cognitive training. And I think there are papers that are weak that are against the efficacy of training. And I think there are papers that are weak that are for the efficacy of cognitive training. And we need to think about that pretty hard and think about why are we still publishing papers that don't meet the standards that we are beginning to agree on? And I think until these issues are resolved and addressed fully, the field is unlikely to move forward. We're doing a good job, I think, of coming up to consensus about what counts and what doesn't count. But I think we have a potential for this field to stagnate unless we not only come up with the idea of what's the best practices, but also get people to adhere to those best practices as well. So those were the things I wanted to say, and I appreciate the opportunity to address and look forward to a lively discussion.
Kristina, we can't hear you. Nope.
You're not muted.
Still no?
Okay, do you want me to come on, Christy? Alrighty, so I am back up here, so forgive me for catching up. So we have a couple questions from our speaker group. Oh, there you go. Go ahead, Christy. I was just going to go over the moderated questions, but you can go ahead.
Now you can hear me?
Yep, you're good.
Okay. So I wanted to thank everybody for those wonderful talks, and I really wanted to just kind of reflect on what I took away from these talks as a group. First of all, I think my primary thought was it's sort of amazing that we have the agreement that we do, given the variability in the methodology and the approaches that we've had to date. So in some ways, and I'm a glass half full kind of person, I think that this is a really good place to start from. But if we're using highly different training targets, training products, different training duration, modalities, different outcomes across studies, and also we are working with different degrees of personalization, different control groups, and different statistical analyses, but where should we start? In other words, this is really building off of Wally's last comment of, is this work feasible? And do we start big or do we start small in terms of our next steps?
I mean, yeah, I can start maybe, and then the others can chime in. So I think it's really about thinking about what it is that we would like to achieve, right? So a question of understanding underlying mechanisms might need another design as opposed to trying to improve certain outcomes that we're interested in. And I see some comments in the chat, for example, from Dr. Belleville here. So if the goal is to improve real world or complex cognitive processes, right, that also might mean another type of training. And here, for example, thinking about these multimodal interventions that were put forward by the finger study or by other related studies, where we are trying to work on different kinds of processes that then in concert might impact the outcomes that we're striving for, is just very different as opposed to trying to figure out what exact ingredient might be working if we, again, trying to train on an NBAC task with very simple stimuli and trying to figure out whether or not that improves certain aspects, so let's say of inhibitory control. So I really think it matters what type of outcomes and what type of purpose that the study has.
Yeah, and then on the other hand, so yeah, we does have some of the evidence on the different type of cognitive training that has been tested in certain patient population or healthy old adults, but just I think we probably, but it has been very controversial and a lot of disagreement, and just having some like later phase, large clinical trial that can kind of trying to validate what we have learned or using a more rigorous design and to test whether it's really generalizable for different patient population or different race ethnic group, that may also be useful. So yeah, just like what Dr. Jaeggi said, it's really depending on the purpose of the study.
Yeah, I'd like to also add, I mean, I have my colleagues here, Dr. Jaeggi and Dr. Lin, are doing fantastic work that's examining mechanism. And I think starting at the smaller kind of mechanistic level before blowing up to something much bigger, I think that's important. I think understanding what is the actual intervention doing and tweaking it until you get to a point of knowing exactly what the intervention is doing, kind of mechanistically, in kind of a very detailed way, and how that's instantiated in the brain. And I think that's a great way to go. But also there's the sense that you also want outcomes. You want to be able to influence people's lives in a meaningful way. And maybe these are two different routes that people can pursue. One is more direct training on everyday activities that you want people to get better at, which is fairly uncontroversial. It's kind of based on lots of kind of decades or a century of learning. And then there's also thinking about cognitive training as an alternative mechanism to also improve this. But yeah, I think there's, at least in my mind, those two routes as to ways to pursue to improve performance of older adults, of people with cognitive impairment.
Thank you so much. I am thinking about so many things, but as you're talking, it sounds like then you're saying maybe the first thing we need to do is sort of tweak or optimize the existing known limitations that we've been talking about, all these little things, rather than focusing on new ingredients for training or new targets for training. Would you all agree?
I would definitely say that understanding some of these relevant ingredients is a very important step forward, right? Knowing exactly what are the features that make people improve in the training task itself, but then also in the next step, right? So how does this translate then to both the near transfer and the far transfer effects? And these might, again, be different questions, and you can manipulate this in different ways, but understanding what are the relevant features is super important in my opinion.
So how much do we think underlying disease pathology matters when we're looking at our different groups? How much is that coming into play?
Yeah, since I've been working mostly in brain agent dementia, so I feel like currently, so there has been like two ways people really has been working on cognitive training, like using two very different approach. On one hand, there has been like this kind of compensatory resisting pathway people can work on and trying to target certain cognitive process. There are no like a compromise early in the brain aging process or in Alzheimer's disease. But on the other hand, there has been some very ambitious goal trying to directly target the brain networks, and they are like vulnerable to the brain pathology. I think currently probably in the formal way has been more promising, but it doesn't mean the latter way it is kind of it is not working. It's just risky, and so in terms of how to work out those details and the mechanism, when we consider all these brain pathology measures are so expensive, and how we can calculate the right sample size. So yeah, it becomes just more complicated.
So do we think that ultimately we're going to really need to have very distinct approaches for different populations that we're working with? So for example, if we want to focus on aging adults who are looking at prevention or preservation of cognitive function versus people who have already begun to have some signs of dementia versus children that we want to enhance or preserve their neurodevelopmental trajectory in the context of some of the neurodevelopmental conditions that they can have.
Yeah, just very quick. So my theory is like a lot of this kind of fundamental cognitive process, like attention speed processing, they are shared across, like they can definitely benefit different kind of groups. Yeah, from children to schizophrenia to mild cognitive impairment. But of course, yeah, given some difficulty for certain group to work on certain type of cognitive training, we may have to develop some of the specific intervention ingredient that can target a certain group, especially for old adults with late stage dementia. It's probably very difficult to engage them in cognitive training overall. But I'm open to any other different perspective here.
Well, definitely practically speaking, also when it comes to the game development, right? So there's no one size fits all, right? So to really coming up with ideal game design, usability, and narratives that captures people's interests, but also ability levels that are targeted to, let's say, different types of diseases, but also different developmental stages. So a game that might work well for children will not at all be interesting for older adults, most likely, and they're understanding some of these individual differences and preferences. So that might work in concert to not only be beneficial in how much that they learn, but also to get the buy-in from the individuals to even complete the training, which I think is a very important factor.
So I see that we have a lot of questions in the chat now, and they're kind of blowing up. So I want to turn it over to Luke, who's going to read us some of those for the next few minutes of our discussion.
Yeah, so great. So I'll try to start with the easy ones, easy quote unquote, the ones that I think have the most direct answer. There's some that touch on topics that we've already discussed. So I'll go to those if we get there. The first is from Chloe. What specific aspects of gamification do you believe might hinder cognitive training?
Yeah, so this is a really important question, and there's not an easy answer to that, even though it's maybe seems like this too. So designing a game that optimally engages participants and also facilitates their learning is complicated. So having features in there, so the example that I showed you in which we manipulated the number of motivational features that we put in there, it's very important to make sure that these are not distracting from the core task that participants are supposed to do. So if people are using more of their intentional focus to track, oh, these are the number of points that I get, or I'm on this level now, that distracts when we do working memory training from the core task. So still put it in these simple words, as long as these features are distracting from the core game, then this is not a good implementation of gamification features. And I'd be happy to also share some papers or others too if Chloe wants to reach out.
Yeah, and also very quick in terms of like even for older adults, like currently this virtual reality training, action game-based cognitive training, those are things. I mean, for older adults it may be difficult to do, but it doesn't mean it's not important for older adults. It just needed to be tested and tailored to the capacity of how older adults can adopt and engage in those activities. Yeah, and also like especially for older adults, the personality are very different. Some are very novelty driven, and then they may be more interested and open to this kind of intervention. So really has to be personalized to some extent when we talk about gamification.
Yeah, and I would just emphasize, yeah, I've done a little bit of research on older adults' video game preferences, and a lot of times people say younger adults versus older adults, but you find that among older adults, there's so many individual difference. Asking kind of what types of video games are appropriate for an older adult is that like asking what type of video games appropriate for a younger adult. They like to play all sorts of different things, so you really have to really individualize at a much I think, finer grain level. And I think that that's certainly a way that you could improve adherence engagement.
So thanks. And on the topic of engagement, a question from Jolene about how engagement's measured across the various studies. You want to comment briefly on that?
Yeah, there are lots of different ways how we can get at this, from very simply asking participants with Likert scales how much effort that they put into the training or how much engaged they are during the training task, to also looking at their performance level themselves, right? If someone trains at the same, so typically in our work, we make the training games adaptive, so they become increasingly harder if people are getting, putting effort in there and getting better. But if someone stays at the same very low level throughout training, that is also one of the very good indices that people are not really engaged. Or if there's a large reaction time variability, that could be another marker also for a focus of attention. So there's multiple ways how to do this. And surprisingly, this very simple self-report measure of engagement has proved to be quite useful. And it's, again, as I showed, it's correlated with how much they improve during training too.
Yeah, and so in our lab, in addition to all the self-report measurement and the behavior measurement, so there are also like a neurophysiological measurement that can be used here. I mentioned the example about measuring the autonomic nervous system continuously throughout the intervention, and also like measuring the facial expression throughout the intervention. So there are novel ways are being tested, and probably others can explore as well.
So another measurement related question on the topic of FAR transfer. So we heard earlier about transfer of specific cognitive function training to things like general intelligence. But this question from Michelle is about measures used for self-reported IADLs or independent activities of daily living. And is there a best one out there, like a common measure? And then, kind of a meta question, how far is FAR transfer and what might be the measurement implications there?
Yeah, I would say from the in older adults literature, so the self-report everyday function or IADL can have like the ceiling effect related issue here. So I would say what we have learned so far, like really doing some objective performance-based measurement, like following what active trial doing the everyday speed, the TI-ADL, or some more like a naturalistic real-world simulated version of TI-ADL may be a good way to go. And also like a testing, depending on the outcome, so like the speed is related to driving capacity. So assess this kind of more like specific cognitive domain relevant everyday function outcome, maybe another innovative way and clinically relevant way. But for self-report, it's from my perspective, it's not applicable at this point, at least in aging population. Yeah.
Yeah, we've had the same problem with community dwelling, cognitively healthy older adults. We give them the kind of standard IADL self-report and ceiling for pretty much everyone. So there's not really much room to improve. But I agree, simulations of IADLs, even in our research, we've used driving simulation as a outcome measure that is meaningful. You can collect response time, collision, but these simulated IADLs probably give you more variability to be able to detect change as a result of intervention.
So maybe on the topic a little bit from Michelle further is in terms of training, to what extent do you assess the level of cognitive function in thinking about outcomes, whether they're more functional versus basic cognitive function, depending on how impaired somebody might be, how, Wally, to use your words, how meaningful outcomes are to the individuals that are involved in the intervention trials. Can you talk a little bit more about that specifically?
So I would say, so primary versus secondary outcome, or are you talking about the mechanisms on the target? So it really depends on the stage of study and the purpose of a study. So for example, if the primary measure, primary outcome here is about the speed, and then the everyday function is the secondary outcome, then the intervention may be very different from if we want to target a global IADL function as the primary outcome. So from my perspective, it's really dependent on what is the research question and what you're trying to achieve here.
Yeah, I think it's challenging. I think one route that people have taken is find a measure out there that's highly correlated with the outcome that you're ultimately interested in. So you think about useful field of view training. Useful field of view training can predict crash rates. So let's see if we can improve useful field of view and then make inferences about crashes. I think the challenge there is that sometimes then it's easy to teach to the test so that you're teaching towards the UFOV test with a task that's very similar to the useful field of view. And then you can make claims that you might have kind of an impact on crash rates. But I guess those proxy measures are one way to go. But then there are challenges with those proxy measures as well.
And then a couple questions that kind of hit on the same theme here is we'd like your comments on different approaches used to train to improve a deficit versus to enhance reserve or resilience, or likewise, do you think differently about acute versus maintenance or durability as your primary targets for training? Comment on that briefly. I know that's a big question, but
yeah, I would say cognitive resilience or cognitive reserve itself is a very complicated and controversial domain at this point. That I understand there are NIH workshop and white paper has been focusing on that. Unless we have a clear understanding how we operationalize cognitive resilience, and we probably can't really. I mean, it's very difficult to put this as a primary outcome in a cognitive training. And that is just my opinion.
Great. Anybody else want to comment on that one, or I'll move forward?
Go ahead.
Okay. So this kind of gets to the big picture overall question, which I'll come back to, which was a couple of people, what do we need? Like, what's the go signal to do that phase 3 definitive trial? So we heard from Kristy with, some questions around, do we just tweak the known factors that we have? Do we explore alternative mechanisms? Do we look more, at more novel designs, like these closed loop style designs? Do we look for more nuanced measures of, brain network function and restructuring? What is it that we need before we jump into that phase 3 trial, or what signal do we need to see given the state of the field where we do find there are mixed findings and lots to work on? Again, a big question, so I'll end with that one. That's kind of the pull it all together, answer that question, and we'll move on. No, just kidding. Anyone can answer.
Yeah. I mean, I can maybe highlight a little bit, maybe something that will be touched on in one of the later seminars, but I really think we need more larger scale interventions, which allow us a couple of things to investigate. One, we can manipulate certain ingredients within this large scale design on one hand. On the other hand, it also would allow us to reliably uncover individual differences that might predict the extent to which people improve in certain kinds of training versus in other sorts of training, and how that again translate to near transfer. And in our lab, we are still in the process of running a trial in which the goal will be to train 30,000 people in different kinds of interventions, which allows us to do exactly that. And also using a machine learning to uncover some of these individual differences, again, in one aspect, but also trying to understand some of these intervention features. So trials like this, I think, could be really beneficial to help the field, and also implementing some of these trials multi-site, right? So we're to help the generalizability one, and also to include a diverse population, to also understand whether certain types of training work for certain people and not for other people, and so on. So large-scale trials.
Yeah, I agree that, I mean, that there's a tension of do you want to figure everything out on a very small scale to be able to kind of build the perfect intervention and then deploy it in mass? But I mean, if it works for only a small number of people within if it works for certain people, if there are important moderators, you won't really know that unless if you run that type of trial, that large trial. And I think the duration of these cognitive training studies is another thing that hurts us, is that we aren't able to look at what is the outcome, what are meaningful outcomes over the next 10 years. Active did that great. Active was able to follow folks up decades, and that's great. And we learned so much from the ability to run a lot of people through the study over a long period of time. The studies that Susanne, those types of studies that you're mentioning, I think what we need. So we may need to jump into the big studies in advance of really understanding everything that we're doing.
Yeah, I agree, and seem like everyone here agree on the importance of the personalization and the individual difference when how they benefit from the intervention. So it also means the large scale trial. Only with the large scale trial, we may have the capacity to understand this individual difference, and also like in terms of the outcome here, with a smaller scale trial, it's very difficult to evaluate like some of the spark transfer effect, which usually means like we need the effect size may be smaller compared to the primary outcome. So we do need like a larger scale trial in order to answer some of the questions, and as for brain pathology, if we are talking about like a certain patient population, so just larger scale intervention can help address a lot of this kind of heterogeneity or diversity or like the pathology related questions.
So thank you. I'll turn it back over to Christy. I know there were other comments in the chat. Appreciate it from all the participants. Sorry I couldn't get to the rest of them. So Christy.
Yeah, as I said, I know that we could talk on this topic for another hour, and I really want to thank the panel for doing exactly what we hoped for in this initial webinar, which was to generate 100 questions that we can hopefully scratch the surface of in the remaining 4 webinars that we have in the series. Thank you for stimulating such a great discussion and for kicking us off. What we hope everyone will do is join us for the remaining webinars, and I want to kick it back to Melissa to send us off.
Thank you, Christy. Thank you, everyone, for submitting your questions and contributing to this discussion. So as Christy mentioned, we'll have the next webinars. If you want to register, the next one will be September 30th. We're focusing on underlying mechanisms, and we will hear from Doctors Claudia Van Bastian, Aaron Seitz, and Sean Green. So just want to thank you for attending this webinar, and see you in September. Thank you.
Thanks everyone for joining.
Thanks everyone.
That was great. Oh, is Melissa gone?
Yeah, she jumped off.
Okay.
Yeah, I wasn't sure whether we should kind of stay on for a second or yeah.
Yeah,
Yeah,
I was
thanks.
going to say on.
I'm staying on, yeah.
Great.
I figured we could chat. Maybe others
Mhm.
already jumped off.
Mhm.
Suzanne, do you have like 5 seconds?
Sure. Yeah, no. Thanks so
Um,
much. That was, yeah, I think it was a good